I'm going to go over two different ways to do this question. First of all, this is how I did it. In all cases, at some point you're going to need to draw this line down here and work out the height of this triangle. I'm not going to go to that straight away. Now we know that the three areas are all equal. But if I draw a vertical in here, then I can see that this area is the same as this area because I've just split a rectangle down the middle. So that must mean that this green area, this part of the triangle, is equal to this purple area, the rectangle, because overall the areas are all equal. So what I can do is work out that this is 2, because remember, there is a line of symmetry going down here, so we just divide the 4 into 2. It must both be, this must be 2 as well. And then if I label this side x, by the way, this is the one we're trying to find, the shorter of the parallel sides of the trapezia, with this being the trapezium rather. So my purple area is therefore 2x. Right, let's work on the green area. Right, well, again, this is also 2. And we're told that it's an equilateral triangle, which means that is going to be 4. We can work out the height of the triangle, therefore. It's a right angle triangle, so 4 squared minus 2 squared square rooted is 16 minus 4 root 12, which I'll leave as root 12, I think. We might have to deal with that in a minute. So 2x is going to be a half times the base, which is of this green triangle, 2, times root 12, the height. These cancel. Therefore, x is going to be root 12 divided by 2. All right, we need to have a little bit of knowledge on surds. So for surds, we can write root 12 as root 4 times 3 inside the surd. Separate it to root 4, root 3. You can, instead of times them together and then rooting, you can root each of them and then times together. That is a rule of surds. I'm not going to go into any more detail on that. Root 4 is just 2, so actually they cancel, which gives us x equal to root 3. Let's talk about method 2 now. This is how the solutions did it, and this, is very similar. So in method 2, they work out this as root 12 in the same sort of way, which means the area of the big triangle is going to be a half times 4 times root 12, which is 2 root 12, which means the overall area, because they're all the same, so the area of the big rectangle is going to be 3 lots of that, which becomes 6 root 12. I think at this point I am going to write the root 12 again as root 4 times root 3, so it becomes 12 root 3. Now, because I know that the area of the triangle is also 4 times some missing value, it's 4 times something gives 12 root 3, which means this length here must be 3 root 3, because I'm dividing through by 4. And remember, we said that root 12 was equal to 2 root 3, so the missing value here is going to be the overall length minus this other length, which gives root 3 as the answer, just like we had before. You know what, I feel like that's slightly more complicated than the way I did it, so I'm pretty happy. I'm happy with both, and I hope you are too.